Now let us see another method which may be a faster method for finding missing element in sequence of elements. So the same example, I have set of elements that are starting from 1 and ending at 12. So 1 to 12, and some elements are missing that are 5 and 8. We already know that. And the previous method was taking order of n square time. Now for making it faster, I have taken an array here. That is array from 0 to 12. The last index is h is 12, so the maximum element is 12, so I have taken an array till 12. So first of all, take an array equal to the size, that is the maximum element you have in the sequence. Then initialize the array with 0. Okay, initialize. Now what to do with this? I'll show you the procedure. See, scan through this array one by one. Now let us see the procedure. See, scan through this single dimension array, taking one element at a time. What to do for each element? First element is 3. Go to index 3 and increment it. Make it as 1. So it was 0, just make it as 1. Then next 7. Go to index 7 and make it as 1. Increment it. 4. Go to index, then increment it. 9. Go to index 9 and increment it. Go to index 12 and increment it. Then go to index 6. Same thing. 1. Increment. 11. Increment. Then 2. Okay, increment. Then 10. Increment. So I have scanned through this array, and for that particular element I have gone into the same index. Like for 11, I went into index 11 and incremented that value. So now in this array I have all those locations marked as 1 for the elements that are present in an array, and the missing element, they have still zeros, like 0, 0, 0. Anyway, this 0 is not there in our sequence. Our sequence starts from 1 onwards, so ignore that one. So from that point, from 1 to 12, if you see, there are 2 places that are still zeros, means the elements are missing. So this procedure looks simple and faster. Yes, what is the work we have done? Let us analyze the time, then I will show you the code. So first let us analyze the time. So the time taken is, we are scanning the list of elements. Yes, then for every element, what we are doing here, at the same index we are incrementing it. So how much time it takes for incrementing it at the same index? Constant time, because I don't have to search anything. Like if it is 1, go to index 1 and increment it. Like if it is 12, go to index 12 and increment it. So the time taken is constant. So majorly where the time is spent, we are scanning through this list of elements, so that is order of n. So yes, the time taken is order of n. So this is the faster method. Yes, this is the faster method. Now this is one of the suggestion which is faster. Now one more thing in analysis. What do you call to this such an array? Now one more thing in analysis. What do you call to this array? See, I have given the name as h. So usually this is hash table. Hash table, we'll learn it later, but the simple implementation of hash table, hash we are saying because whatever the element is, we are going to that same index and accessing it. So this takes constant time. Remember that hash table takes constant time, that is ideal time for hashing is constant. So this is taking constant time for storing those elements here, right? So this is hash table, or else we can call it as bit set. So we are taking the set of bits for each number and we are marking them, and whichever are zeros, those elements are missing. Yes, this bit set, we have not implemented the complete mechanism of hashing technique, like using a hash function, all those things, but this is the simplest form of hashing. Remember, whenever you have to search, you can apply hashing if possible. Then one important thing about hashing, when you are using this array as a hash table and storing the elements, then you need an array space equal to the largest element. So it is 1 to. So this may take a lot of space. So space, if it is a constraint, then you cannot use this hashing. Means if you have limited space, then you cannot think of hashing. But nowadays the machines that we are using, they have abundant memory space, so we hardly bother about memory space. So hashing is a best solution whenever you are searching something. So yes, we have used hashing and reduced the time. See, remember in the previous method the time was order of n square. Now it has reduced to order of n. It's a big change. And using this approach you can solve various problems. So this you can take it as a basic idea, not just a solution to a problem. Now I will write down a piece of program code and I will explain. See, for writing a program, first of all, I must have array of elements, list of elements, starting index and the ending index and the number of elements. And also I should have an array. Dynamically you can declare an array of that given maximum size and you can initialize it with 0. So assume that that part is already there. Just I will scan through this list. So for scanning through this array, I will take a for loop for I assign starting from 0 and I is less than number of elements that are n. So less than n, I plus plus. Then what I should do every time? See, if the number is a 3, a of I initially is 0. A of I is a 3. So I should go to index 3 and mark it as 1. So increment it. So a of I, which is 3. So I should go to that index in h. So h of a of I, that I should increment it. That's it. So it will scan through this array and for every element in that particular index, it will increment it. So this for loop will increment wherever the element is found. Then I have to scan through this array and find out missing element. Wherever is 0, that element is missing. Simple. So I will write on one more loop. This is over, right? After this, the next for loop for I assign, I should start from which element? This element to this element, that is low, and I is less than equal to high, I plus plus, right? So I should start from 1 and add 12. Then every time I should check if h of I is still 0, means element is not there. So simply I will printf. Which element? Like h of 5 is 0, so 5 is not there, right? So printf percentile d, new line, and I will say I. So that is index. So that's all. In a single line I have written it. So this for loop is for scanning through this array and this for loop is for scanning through this array. So this is also order of n and this for loop also number of elements are n. Total it is 2n, so I can say it's order of n. Degree of a polynomial is n. So this for loop n times. So n elements, so 2n and time is order of n. So that's it. So you can write down this program and check it. So you can directly write inside main function, and you can execute this program. So this is a student exercise. So you have to do this one. That's it.